Okay, let's go through this practice test. Question 1. Solve the following linear equations. Okay, for this first one, we're going to start by getting rid of that 3. So remember, always our goal is to isolate x. I could start by expanding the brackets, but it's going to be easier here if I start by just eliminating that 3 straight out, which I can do because I noticed that on the other side, if I divide by 3, it'll give me a useful result. So I'm going to do 3x plus 5 equals 9, and I'm going to divide both sides by 3. That's going to give me these 3's are going to cancel, and so I'm going to get x plus 5 equals 9 divided by 3 is 3. So if x plus 5 equals 3, then x must equal 3 minus 5, so x equals negative 2. Question B involves fractions. The way I'm going to do this question is by making every term in this equation over the same denominator. So let's put everything over a denominator of 6, and then I'll be able to cancel my denominators out. So to get 2x minus 1 to have a denominator of 6, I need to multiply it by 3. So I'm going to get 3 times 2x is 6x, and 3 times negative 1 is negative 3, so I put that over 6, plus 4 minus 5x over 6, and that equals 4. Now remember, I need to put this over 6 as well. Everything needs to be over 6 if they're going to be able to cancel. So to put 4 over 6, currently it's 4 over 1. So I multiply both sides of that fraction by 6, and it gives me 24 over 6. Now that every single term in my equation is over 6, I can cancel those out. So I'm going to get 6x minus 3 plus 4 minus 5x equals 24. I'm going to collect my like terms, so I get 6x minus 5x gives me x, just 1x, and negative 3 plus 4 gives me a positive 1, and that equals 24. And if x plus 1 equals 24, then x must equal 23. Question C. For this one, I've got an x on both sides of the equation. That's the first thing I notice. And I've got a bracket there. So unlike that first one, where I could just get rid of the number in front of the bracket straight away, that's a lot harder to do here because I've got a much messier, it's a bit messier on the side of the equation that doesn't have the bracket. So I'm going to start by actually expanding that bracket. So I'm going to get 5x plus 7 equals 3x minus 3. Now I'm going to collect my like terms, so I'll take the 3x over to that side by minusing 3 from both sides. So 5x minus 3x gives me 2x, and negative 3 minus 7 is negative 10. That means that x must equal negative 5. And question D, 2x plus 3 equals 3x plus 1 over 2. The first thing I'm going to do here is get rid of that bracket, get rid of that fraction. So I'm going to multiply both sides of the equation by 2 so that I'm not dealing with any fractions. So if I multiply both sides by 2, then that 2 on the bottom of the fraction there is going to cancel. And this is going to be multiplied by 2, so it gives me 2 times 2 is 4. X plus 3 equals 3x plus 1. Now it's almost exactly the same as question C. So I'm going to expand my bracket on this side. I get 4x plus 12 equals 3x plus 1. I'm going to collect my like terms. I minus 3x from both sides. So on the right-hand side, 3x minus 3x is going to cancel. On the left-hand side, 4x minus 3x is going to give me 1x. And then I am going to collect my like terms here by minusing 12 from both sides. So if I minus 12 from the left, it'll give me 0, they'll cancel. And if I minus 1 minus 12, gives me negative 11. Okay, let's move on to question 2. Solving sets of simultaneous equations. Okay, so for this question, I could do this by substitution or by elimination. It doesn't matter which one you do. I'm going to choose to do this by elimination. Just because it looks like it might kind of be easier that way with the numbers that I have, but you do whichever one you feel more comfortable with. If I've got equation 1 and equation 2, I want to start, my first step is to multiply one of these equations by a constant so that I can eliminate one of my variables. So if I multiply equation 2 by 2, that's going to give me 4x, 2x times 2, plus 3y times 2 is 6y, equals 22 times 2 is 44. Now, if I call that equation 3, I'm going to do equation 3 minus equation 1. So that gives me 4x minus 4x cancels, which is exactly what I want. 6y minus y gives me 5y. And that equals 44 minus 14, which gives me 30. Therefore, I get that y equals 30 over 5, which equals 6. Now that I found that y is 6, I can put that back into one of my equations to solve for x. So let's put it back into equation number 1. I get that 4x plus y, which we now know is 6, equals 14. And so 4x equals 14 minus 6, which is 8, and therefore x equals 2. So I've solved my equations. I get that x equals 2 and y equals 6. Question 3. These are all of our favorite questions, the tricky worded ones where we have to write the simultaneous equations before we solve them. The father is 27 years old when his daughter is born. If the age of the father is x and the age of the daughter is y, write an equation relating x and y. Okay, so the way that I like to do these is by starting with an x equals y, spread apart like that, and then thinking, what do I need to add to this equation to make it true? So if this x is the father, and that y is the daughter, and the father was 27 years old when his daughter was born, then what do I need to add to one of the sides? I need to add 27 to the daughter's age. So now I have, if I take the daughter's age, and I add another 27 years, then I'll get the father's age. Question B. Today, the father's age is triple what the daughter's age will be in 3 years. Use this information to write another equation relating x and y. Okay, same thing. The father's age is, so is English for equals. So the father's age x is equals triple what the daughter's age will be in 3 years. So what will the daughter's age be in 3 years? That'll be y plus 3. And then I need triple that. So I do 3 times y plus 3. So that is triple what the daughter's age will be in 3 years. And that will equal the father's age. Now, how old is the daughter today? So for that, I need to solve these two equations simultaneously. And I'm going to use substitution, because I notice that I've got an x equals something and another x equals something. So I'm going to take this value for x and substitute it into this equation. So I get that y plus 27 equals 3y plus 3. I'm going to expand my brackets, so y plus 27 equals 3y plus 9. And now I'm going to collect my like terms. So let's get rid of the y on the left-hand side here by minusing y from both sides. So y minus y on the left is going to cancel. 3y minus y on the right is going to give me 2y. And then I'll get rid of the 9 from the right-hand side by minusing 9 from both sides. So 9 minus 9 is going to cancel, and 27 minus 9 is going to give me 18. If 2y equals 18, then y equals 9. Now, the question was, how old is the daughter today? And since I've just found y, which was the daughter's age. I don't even need to do that last step of substituting back to solve for x, because I've answered the question. I found how old the daughter is. That is the end of the non-calculator section of this practice test, so I'll make a separate video for the calculator section.